Hey students, this is Mrs. Tran-Bloom. So our note today is on section 2.4. Our title is Solving Quadratic and Polynomial Functions. And for this type of solving, we are studying solving by factoring only. Now, there are definitely more than one ways to solve, okay? As you can see here. But for this particular unit, we're only going to study solving by factoring. We will learn the other ways in the future units. So the solutions to your quadratic or your polynomial equations are the x-intercept, or sometimes x-intercepts can be called the roots, okay? This means that's when the graph touches or intersects the x-axis. That's what the x-intercepts mean. Now, this is a really important property here that we need to study for algebra. If we have two products called A and B, so if A times B equals to 0, then to B equals to 0, one of it's got to be 0. So either A equals to 0 or B equals to 0. This is only when it equals to 0. That's why the title says zero product property. Now, you guys already kind of went over the perfect trinomials here. So if you could take a minute to fill out the blank lines for the perfect trinomial, that would be great, okay? So we're going to go up and do some examples. We will start with example 1, solve. Okay, remember, solve means we need to isolate x. And for this particular unit, we're going to try to see if we can factor this. And by now, I'm hoping that you guys are super fast at factoring. So we have x squared plus 9x plus 8. Okay, to factor this out, you can pause and factor however you would like to factor. But your two factors should be x plus 3 times x plus 6. Remember, I would like for you to pause it and make sure you guys can come up with the same two factors. Once we have the two factors, students, we are going to use the zero product factority. Okay, zero product property. If A times B equals to 0, then one of it's got to be 0 or the other's got to be 0. So that's what we're going to do. We're going to take each factor and we will set it equal to 0. So the first factor is x plus 3. We will take that and set it equals to 0. The second factor, x plus 6, set that equals to 0. And then we're going to solve for it normally. Okay, so minus 3 from both sides. That means this is going to cancel. Our first x is going to be at -3, minus 3 from both sides. Our second x is going to be -6. I'm going to write this in order from -6, comma, -3, and we are going to box this up. Let's go do example 2. 6x squared plus x minus 15. And again, this is a trinomial, so let's see if we can factor this out. Now, the leading coefficient is 6, students, so I'm going to give you guys a quick refresher on how to factor trinomial when the leading coefficient is not 1. Okay, so A is 6, B, this is the 1, so B is going to be 1, and then your C is going to be -15. Now, according to our older sections here, we're going to make a chart where we have A times C and then put B right here. Well, A is 6, okay, I'm sorry, C is -15. Woo, C is -15, don't forget, right? So A is 6, C is -15, so we will multiply those two together. 6 times -15 is going to be a -90. We would like to find two numbers multiplied equals to -90 and add it together to give us a B value, which is a 1. So we know 9 times 10 is 90, but we need -90. And in math, guys, if we know that when we add equals 1, so that means a bigger number has to be positive. So that means this is a -9 times +10. So -9 plus 10, that is definitely 1. So we are golden. So those are the two numbers that we are going to use, okay? So rewrite this as, I'm going to factor by grouping here. If you use the box method, do your box method. If you guess and check, then guess and check. So 6x squared is on the front, -15 is in the back. I'm going to write -9x, okay, and a +10x. No, you don't have to write like that. You can write +10x and -9x. Then we are going to factor. Remember, these two terms right here must add up to be 1x, and it does. So I am factored by grouping. So 6x squared minus 9x, students. I know 6 and 9 will have a GCF of 3. X squared and x, we can also factor out an x. So 6x squared divided by 3x is 2x. 9x divided by 3 is going to be 3, but there's a negative, so we know it's minus 3, okay? Now this is a plus sign, so we will drop that down. 5x and 15, we know there is a 5 in common, right? 10x divided by 5, student, that's 2x. Negative 15 divided by 5, that's a negative 3. Ooh, yay. Those two factors, they are exactly the same. So that means we can factor that out. So we factor that out. That means we are left with a 3x plus 5. Okay, remember, it equals to 0. So we have to make it equal to 0 here. Then factoring is done. We will now take each factor and we will go into set it equal to 0. 2x minus 3 equals to 0. And then 3x plus 5, students, equal to 0. Remember, here's when you solve for it normally, okay? Add 3 to both sides. So now we have 2x equals 3. Divide both sides by 2. X is going to be 3 over 2. You could write 1.5 if you want. Then similarly, minus 5 to both sides. Then we are going to end up with 3x equals negative 5. Divide both sides by 3. Okay. X is negative 5 over 3. Can't really reduce that, so leave it. If you want to write it as negative 1 2/3, that's okay by me. I'm going to write this in order from smallest to biggest. So negative 5 over 3, comma, 3 over 2, and box that up. All right, we're still in the direction it's solved. So first step in factoring, students, is check for GCF. Checked GCF always. Looks like we all have an x here in common, okay? So let's factor that out first. If we take out an x, we should have an x squared here, minus 10x here, students, and then a 25, okay? So technically, these are definitely two factors. So technically, we can start out setting each factor equals to 0. But if we look at this, isn't that a perfect trinomial? So let me pinch it in and then kind of give you a look of what I mean by that. Okay, so earlier we had this. So if we have that, and our factors are x plus 5 quantity square, but over here we have a minus 10 in the middle. So that means when we factor that out, remember, we always have to factor completely, right? So when we factor this out, it should be x minus 5 times x minus 5, or you can write x minus 5 quantity square. Then we are going to take each factor and we set equal to 0. Oh, this one, no work needed. First x, wham, 0. Now guys, these two are exactly the same. So technically, I don't have to write it out twice because the answer would be identical. So if you have two identical factors, do not need to write it out twice because it's just going to be more writing for you when it's not needed. So students, we here have two answers. X equals to 0, comma 5, and box that up. Okay. Over here, ooh, two terms. And each term looks like they are perfect square, isn't it? And there's a minus in the middle. Oh man, I wish there's a name for this. Oh, you mean the difference of two squares? Yes, it is. So this is something square minus something square. So this is the difference of two squares. Okay, difference means subtract. So if you guys remember from our prior section of factoring difference of square is like this, okay? So our A for this one is x. Our B for this one, students, is 4. So difference of square always have two sets of quantities since there's no GCF. So first is x minus 4, or you can write x plus 4 first. And then the other one is whatever you have not written. Since that's a two factor, we would take each factor and set it equal to 0. And we solve for this one normally, add 4 to both sides. So our first answer is x equals to 4 minus 4 from both sides. So that's going to give us -4. So let's box up our two answers. Let's write it from smallest to biggest, just kind of organizing it nicely. All right, so example 5 says -3x to the third minus 24x squared plus 11x plus 88 equals to 0. Let's check for GCF first. -3, -24, 11, and 88. We don't have one GCF for that one, and especially x to the third, x squared, x, and then 88 doesn't have an x. So right now, currently, no GCF, so we are just going to factor by grouping. Well, how do I need to factor by grouping? Because we have 4 terms, okay? So the first two groups, as you can see, students, I'm definitely going to factor out a -3 because I know a -3 goes into a -24. They both have x cubed and x squared, so definitely they both have x squared in common. Remember, factoring out means we are dividing, right? So if we were to divide each term over here by -3x squared, that's going to leave us a positive x. -24x squared divided by -3x squared, positive 8. Okay. Over here, we're going to drop down this plus sign. So take out an 11. That means we are going to divide this by 11 and divide that by 11. So that's going to be x plus 8. Now, remember, we love it when these are in common because we know that's what we need to factor out. If we factor that out, okay, that means we divide this whole chunk by x plus 8. Divide this whole chunk by x plus 8. That's what factoring mean. Those will cancel. Those will cancel. So now you guys have -3x squared plus 11. Remember, it still equals to 0. So let's make it equal to 0. Then now we will take each factor and set it equal to 0. X plus 8 equal to 0, students. And then -3x squared plus 11 equals to 0. And we are going to solve it normally, okay? So this is going to be x equals -8. Over here, we will subtract both sides with -11. Then we have -3x squared equals to -11. Now we will divide both sides. Let me extend this line. We will divide both sides by -3. So a -11 divided by -3, students, that is definitely a positive 11 over 3. We would now square root left, and that means square root right. Every time you take a square root, students, you need to have a plus and a minus. You would have two answers, okay? Now, square root of 11 over 3, students, that's the same thing as breaking it up to square root of 11 independently and divided by square root of 3, just like that. Then we do need to rationalize your denominator, meaning that we need to multiply the top by the same thing as the bottom. In this case, it's going to be a square root of 3. Well, a square root of 3 times a square root of 3 is square root of 9. Square root of 9 is back to 3. On the top, we would have a square root of 11 times square root of 3. We can put it back together under one big radical. So plus or minus square root of 33 all over 3. So two answers and one answer. Let's put it together. X is -8, comma, plus or minus square root of 33 all over 3. Now you can even write it like this. X equals -8, comma, negative rad 33 over 3, comma, positive rad 33 all over 3. Either one, it's okay because they represent the same exact set of answers, okay? Example 6 says x to the third minus 27 equals to 0. Now, students, can you guys recognize that this is difference of cubes? So something to the third power minus something to the third power equals to 0, right? So when you see this, x goes here because x to the third is x to the third. Well, 3 to the third is 27, and there's a minus sign in the middle. So this is definitely difference of cube. So a is x, and then your b is going to be 3. And if you guys remember sum and difference of cube, we studied this already in factoring. The formula is a minus b times a square, whoops, times a square plus ab plus b squared. So again, if you guys need help with factoring, please do come into office hours and get some extra help. So let's factor it out, okay? So this is going to say a minus b. Well, a is x, b is going to be 3, so a minus 3. A square, well, a is x, so that's going to be x squared. And remember, this is going to be opposite sign because it's SOAP, right? SOAP means same sign. Whatever the sign you start out with, the first one's going to be the same, and then opposite, and this one is always positive. So it's going to be opposite. It's a times b. A is x, b is 3, so 3 times x is 3x. And then it says b squared. Well, b squared is 3 squared. Well, 3 squared is really 9. So if we want to write that back down, it would look like this. And remember, we're solving, so we need to make sure that we take each factor and we set it equals to 0. Okay, so, and then over here, x squared plus 3x plus 9 equals to 0. Now, let me roll up. So we are going to see if this trinomial right here, students, is factorable a little bit further. A is 1, b is going to be 3, and c is going to be 9. How do we check to see if it's factorable a little bit further? We make your chart to see if it's going to work or not. A times c is going to be 1 times 9 is 9. Your b value is 3. So could we possibly find two numbers, multiply, equal to positive 9, and add equals to 3? And the answer is really not possible. So this is not factorable anymore. Okay, not factorable. So right now, it's not factorable, so we don't need to go any further. Now I'm going to give you a hint, because in the future, not factorable, this trinomial coming from the sum of difference of cubes is going to give you imaginary numbers. So this is not real solutions, okay? So but right now, we don't need to worry about this. All right, so that means we only have one real answers over here, students. We take this and we set it equal to 0. So this question only has one answer. The answer is just going to be x equal to 3, because the right side, x squared plus 3x plus 9, is not factorable, so we don't need to worry about the answer for that one. So I'm going to unhighlight the box, unbox it, okay, because I don't need you to worry about this right now. So it's not going to be a real answer, so we don't need to write it in. Example 7 says x times the quantity of x minus 2 times the quantity of x plus 4 times the quantity of 2x plus 7 times the quantity of x minus 1 equals to 0. And remember, we are still solving. So it looks like, let's see, 1 factor, 2, 3, 4, 5. 5 factors, students, and they already factored this out for us. So yay, we don't have to really do a lot of hard work. Take each factor and just set each factor equal to 0 and solve it regularly. Yay, look at that, one answer, done. So x minus 2 equals to 0. Some of you can see that, oh, well, isn't the answer 2? Yes, you can write that straight up. But I'm just going to take each factor and set it equal to 0 first, just in case some of you guys still need to see how we solve each factor, okay? So each factor equals to 0. This one is done, so there's no work needed. But this one, add 2 to both sides. So here's our second answer. This one, minus 4 from both sides. So that means x equals to negative 4. This one, minus 7 first. So that's going to be 2x equals negative 7. Then next, we will divide by 2. Then that's going to give us an x equals to negative 7 over 2. Yes, we can definitely write that as negative 3.5, or some of you guys were like, oh, well, could I write it as negative 3.5? Yes, you can. Any one of these is fine. And our next one is going to add 1 to both sides. And yes, if you can see that x equals to 1, you can go straight there. So we have 1 answer, 2 answers, 3 answers, 4 answers, and 5. Let's write these in order from smallest to biggest. Let's see. The smallest is going to be some negative numbers. So it looks like negative 4 is the smallest here. Okay, and then next it looks like negative 3.5 here. So negative 3.5. Looks like 0 is next in line. So 0. Okay, so those two are done. And then we have a 1 and a 2. 1, comma 2, and then highlight this if you have a highlighter. Box this up if you have a box. Okay? Okay, example 8. 4x squared plus 49 equals 0. First, let's see if this is factorable first. So we have 4x squared plus 49. It appears that these are both squares. Okay, so let's see if you can write this as square. So 4x something squared. So that means 2x quantity squared will give us 4x squared. And then 7 squared will be 49. But here's a dilemma. We know that the difference of 2 squared is going to be factorable. But remember, the sum of 2 squared is not factorable. So this is not factorable. Okay? If it's not factorable right now, we don't need to go further. Now, let's say that you didn't realize that this is not factorable. And then let's just say that you go and keep on solving. So first you would minus 49 from both sides, just like this, okay, which is totally acceptable. Remember, mathematics, there are multiple ways to get here. Then next, you're going to go, okay, I'm going to divide both sides by 4, which is perfect. Good job if this is how you want it to go about this. Then next, we are going to undo the power of 2, which you guys know, okay, well, I'm going to take square root of both sides. But here's the dilemma, right? The negative under the square root, this is not going to give us a real answer. So right now, we haven't studied imaginary answers yet. So if it's not factorable, you can move on. You don't need to go any further, okay? So right now, not factorable, you don't need to go any further. Okay, so our next 3 questions, students, it says find the x and y intercepts for each function algebraically. So x-intercept, as you guys remember from last unit, is when y equals to 0. So let's start with that. So x, and we need to set y equals to 0. Well, that's the same thing as we were y equals to 0. It's y is the same as f of x. So we're going to take f of x, we make it equal to 0. So 0 equals 3x squared plus 6x minus 9. Well, isn't this the same thing as solving? Yes, it is. So check for GCF. GCF is going to be 3. So let's factor that out first. Okay. So that means we're left with x squared. 6x divided by 3 is going to be 2x. Negative 9 divided by 3 is negative 3. Then let's see if we can factor this a little bit more. This is going to be 2 factors here. We have a negative 3, so x plus 3 times x minus 1. Remember, this equals to 0, so we're going to just take this and set it equal to 0. So now take each factor and set it equal to 0. 3 equals to 0. Well, let's think about that. Is 3 ever going to be 0? So that's not true. We don't need to keep it, okay? So next, x plus 3 equals to 0. X minus 1 equals to 0. So that means x is immediately negative 3. And then over here, x equals to 1. So remember, x-intercept, we have to write it as an order pair. So we have 2 x-intercept, negative 3, comma 0, and 1, comma 0. So these are the x-intercept. Y-intercept is when x equals to 0. Let me pinch it in because I need to go down here. So y-int is when x equals to 0. So we have, students, f of x, which is the same as y equals. X equals to 0 just mean that every time we see an x, we have 2 x locations here, 1 and 2. The first one is square. The second one is 6 times x. That's not square, and then minus 9. 9 does not have an x. So that means we substitute in 0 for x. That's what we said. Well, 0 squared, students, is going to be 0. 0 times 3 is 0. 6 times 0 is 0. Drop down the 9. So these are both 0. So that means your y-intercept, students, is going to be a negative 9. So your y-int, write it as an order pair. X is 0, comma, negative 9. So you have 1 y-intercept and 2 x-intercepts. Example number 10. Similarly, we will do it the same way. We will start out with x-intercept, meaning that we will set y equals to 0 and solve for it normally. 0 equals x minus 7 to the third power minus 1. Step number 1, add 1 to both sides. Yes, this is totally okay to do. So 1 equals quantity x minus 7 to the third power. To undo a square power, we take a square root. To undo a third power, we take a cube root, okay? So a cube root of a cube root of positive 1. It's kind of like this. Well, positive 1, students, a cube root means we need 3 items to take it out. Well, 1 times 1 times 1 is 1. So that means cube root of 1 is just simply 1, okay? Over here, cube root of this. Okay, let me kind of explain that to you. This just means a power of 3 means we can write this out 3 times. That's what powers mean. Just kind of the product repeating. Well, since it's a cube root of 3, let's put that 3 in the little corner here. That means we can take one of it out. That's exactly what that means. So now we have 1 equals x minus 7. Add 7 to both sides. So our x is going to come out to be 8. So we have one x-intercept. Write it as an ordered pair. 8, 0. Box that up for the x-intercept. Y-intercept, we will do it in the same way, except now y-intercept, we set x equal to 0. Y-int x equals to 0. Okay, let's see. We have one x location only, so that shouldn't be too bad. Y equals, I see my first x location, chug in a 0. Okay, and then drop down the non-x things. So negative 7 to the third power minus 1. Follow PEMDAS. So 0 minus 7, students, is going to be a negative 7 to the third. Okay, PEMDAS says you need to do exponents, so make sure we do that next. Remember, we already studied perfect cube. So negative 7 times negative 7 times negative 7, aka negative 7 to the third, is just going to be a negative 343 minus 1. So that's a negative 344. Write it as an ordered pair. 0, negative 344. Box that up. Okay, our last example. Y equals 2x to the fourth minus 3x to the third minus 20x squared. And again, it's the same set of directions. So let's start with the x-intercept. Again, we're going to take it and set it equals to y, 0. So 0 is 2x to the fourth minus 3x to the third minus 20x squared. And students, this is no difference than just solve, okay? Let's check for GCF. 2, 3, and 20, we're not going to have anything in common with the numerical value, but it has an x to the fourth, x to the third, and x squared. So our GCF, students, is definitely x squared. So divide each and every term by x squared like this. Divide this by x squared, divide this by x squared. So we are still going to be left with 2x to the second minus 3x and minus 20. Okay, we need to factor this completely. So our A is 2 for this trinomial. Our B here is negative 3. And our C here is negative 20. So when we make a chart for A times C and the B goes here, so our B is negative 3. And our A times C, 2 times negative 20 is negative 40. Two numbers multiply equals negative 40 and add up equals to negative 3. Well, we know 5 times 8 is 40, but we need a negative 3 to happen, so we're going to do a negative 8. So 5 plus negative 8, definitely negative 3. So 5 times negative 8 is what we want, okay? So let's rewrite this back down, x squared, and then we're going to rewrite this 2x squared. We're going to hold off on this because we need to, I'm going to factor by grouping. You can factor however method or whatever method you would like. I'm going to copy the last term, which is negative 20. Instead of a negative 3x, I'm going to write it as a positive 5x and a negative 8x, guys. And then I'm just going to factor by grouping. Here we go. 2x squared plus 5x. X is in common. Take that out. So I'm left with 2x plus 5. The negative is here, so I'm going to drop down the negative. 8 and 20, definitely a 4 in common. In this case, I'm dividing by -4, as you can see. Let's see this. -4, divide this by -4. So that means -8x divided by -4 is positive 2x, okay? -20 divided by -4 is positive 5. So this and that, those are identical. So that means we are good with our factoring. What's left is going to be x minus 4, but don't forget this is an x squared. Drop that down. And remember, we are still solving for x-intercept, so set that equals to 0. Now take each factor and set it equal to 0. X squared equals 0. 2x plus 5 equals 0. X minus 4 equals to 0. Well, even if we square root both sides, students, that means it's x equals plus or minus 0, but 0 doesn't have a plus or minus, so x equals to 0 is our answer here. Minus 5 from here, minus 5 from here, so that means I'm going to have 2x equals -5, divide both sides by 2, okay? So that means we have x equals -5 over 2, aka -2.5, aka -2.5. And then this over here at 4. So students, x equals 4. Okay. So order pairs. 0, 0. That's our first one. -5 over 2, 0, our second. And third, 4, 0. Those are all 3 x-intercept that we have to write as order pairs. Now, y-intercept is when x equals to 0. So let me pinch this in because I need to see the original equation really quickly. Y equals 2x to the 4th minus x to the 3rd minus 20x squared. Ooh, we have 3x locations. So what that means, students, that means we need to substitute x in 3 different times, right? So it's going to go y equals 2 times, I see the first x, wait for that to happen, minus second x was raised to the 3rd, minus 20, the third x was raised to second. So every time x is in the equation, we substitute with 0 because we're looking for y-intercept. Well, think about this, guys. 0 to the 4th is 0. 0 to the 3rd is 0. 0 squared is 0. Well, these are currently 2 times 0 minus 3 times 0 minus 20 times 0. That means it is 0. So your y-intercept, guys, let's write it as an order pair. 0, 0, and box it up. Whoa, whoa, whoa. We are done.